Alright, I'm going to lay out the engine where I'm going to lay it out and remove the material, a huge amount of material from to actually create the shape of this thing. I broke down and bought some Dykem. You hit the block. The material has to be clean, no oil on it when you use this stuff. And I could have cleaned it with this firearms degreaser, but this stuff's kind of expensive. So I cleaned it with warm soap and water. It's aluminum, so that's fine. In my wife's sink, which I'm sure she wouldn't mind if she knew about it. Warm soap and water's fine. I don't really know much about using this stuff, but I think you just spread it on lightly or to the thickness desired and let it dry. Oh, I think that's the thickness desired. I'll let it dry. It's time to lay out the engine on this block. I usually, well, not usually, almost never use layout fluid and scribe lines. I usually go by the dials on my mill, but I'm going to do this one differently. I'm going to lay it out and see if that's an easier way to do it. I suppose on something that doesn't have to be incredibly precise, or as precise as I could make it, laying it out like this would be fine. I'm going to lay out the valve body first, and it should be 1.3125 inches. I'm looking at my drawing, which I'd shown earlier. This side is the valve body side, so I've already zeroed my height gauge, and I'm not completely expert in using this thing, that's for sure, because I didn't have a surface plate, but now I do. So I'm fighting to get it at there's 1.31. Let's see if I can get it at oops, passed it up, 312 something. There we go. I wonder if it's possible to tap it to 5. Oop, missed it. Oop, missed it a lot. So, I guess you could screw around doing this a long time. There's 3125. Let's see if I can tighten it up without changing it. Nope. Well, anyway, I'm going to get this set at 1.3125 and scribe across here for the valve body, and then at 1.5, a little higher for the cylinder, and then I'll do the upright, and life will be good. Now I see the convenience of gauge blocks, which I don't have, and if I had, then I could set the height gauge about to anything I wanted, instead of fumbling around, pushing them, tapping it up, tapping it down. I thought about using my gauge pins, plug gauges, but I didn't want to wipe the grease off of them or the oil that I've so carefully put on one of them. And plus, they're plus or minus anyway. So I saved. I'm going to bring you in here on the exciting scribe, one of the exciting scribe marks. Full length of, not the full length, but that'll define the pedestal. Which is 1 inch from the bottom there. Then the other one, well, I don't know what the other one is from the top. I don't know what it is from here, but I know what it is from this scribe mark. It's 1/4 inch. So I'll do that next. Okay, I've got the height gauge set at 1.25 inches on the money. I like to make the scribe marks rather deep, well, deep into the diachrome, but I want the actual marks left on the aluminum, because by the time I mill on this for a little bit and keep squirting with WD-40, the diachrome is going to disappear. So this is what the engine basically is going to look like. This is the base, and here's the pedestal, and the cylinder will be here, and the valve body here. So now we've got to figure out how to remove a lot of material, both here and here. I don't have a vertical bandsaw. All I've got is a horizontal one. I've got a good one, but I can't remove any material. I can't remove this with it. There's just no way. So I think the only option I have is an end mill. It's going to produce a lot of chips. I'm going to use this 3/4 inch end mill to remove all this material, both on the cylinder side and the valve side, and I imagine I'll use it for the finish cut as well, but we'll have to see what it looks like. I'm using a 2-flute end mill because it clears chips better, a lot better than a 4-flute. Or I've even got 6-flute, which I definitely don't want to use in this for this task. This is a 2-flute high-speed steel TIN coated end mill from Grizzly. I've had great luck with these TIN and the uncoated high-speed steel end mills from Grizzly. Years ago, I used to buy replacement 3/4 inch end mills from Grizzly, but they don't offer them anymore. I think I did. I bought them from Grizzly. But now, when I have to replace any cutter, I buy Made in USA. And my stock is beginning to take on that entire Made in USA flavor. Plus, I've got an enormous number of cutters that my dear brother-in-law, who lives in Detroit and is an estate sale junkie, has picked up for me and shipped to me on various occasions. And they're just invaluable. They've got old names on them that everyone would recognize that's been in the business for a while. And Bernard, if you ever see this video, I love you, pal. You need to go back to some more estate sales. Now I'm trying to figure out the best approach on actually removing this material. I don't want to start off by going back and forth, although it'd be neat because I could use the power feed on the x-axis. However, I'd have to hit this line and this line every time. I'm thinking about I'm already aligned with this line. I'm thinking about going to full depth, down 1 inch, incrementally, of course, here, and then coming over here and aligning with this line and doing the same thing, and then I'll have a 3/4 inch cut here and a 3/4 inch cut here, and then I can use the power feed back and forth between those two cuts and not have to worry about stopping here and stopping here. I'll stop in that gap right there and this gap right here. That's the plan right now. I bet it changes before I finish. Okay, things are looking good. This is the final cut of 50 thousandths. It'll take me down to 1 inch on that end. The side finish could be a whole lot better, but the bottom finish is looking real good, and I could dress the side finish up later. So now I'm going to come down to this end and make the same cut. I'm thinking that TIN end mill that I used on the first cut had a problem. I'd switched to this high-speed steel end mill, 3/4 inch, and it's cutting like butter. It even sounds a lot better. I'm taking, instead of 50 thousandths, I'm taking 100 thousandths. I could easily take more. There's less, it requires less force on the hand wheel to cut, and as I mentioned, it sounds great. I'll back the camera out and let you hear a pass, but notice the bottom of the cylinder is now showing. I'll stick my finger in it. Can you see? Yeah, I guess you can see it. I can see it. So I'll back it out and take a pass. Down 100. Tell the difference in the sound, but that was a lot better. And the finishes on the side milling finish is great. The problem with using scribed lines is you got to sneak up to them. And if I'd been using the dials, that'd be, right on. So I'm going to sneak up to this line. I think I've got it about lined up. If anything, I might be a little short, which would be fine. I can sneak up a little more. It's something like somewhere between 50 and 62 thousandths, I think, is the material left that I need to take off. Well, I did not change end mills. I kept the two-flute high-speed steel end mill. Remember earlier I said I was going to do the finish job with a 6-flute high-speed steel end mill, but I don't see any need. This is a good finish. The line disappeared, so I'm calling that on the money. Now, I will, I don't have anything to point with. Yeah, it is. I will mill this section out. I'll do that on the XY axis. It'll be a lot faster. The question is, how much will I take side milling on each pass? I don't know yet. I'll have to experiment. I got to find the remote control for this camera. It's a, what is it? It's I don't even know what it is. Oh, it's a Canon HD CMOS Pro. I bought it to take videos of grandkids. But the iPhones got so good, and they're so handy. I'll leave the Canon home, and I'll leave my Nikon D700 at home, and just use the iPhone 6. I've got an iPhone 6 Plus, which fits in my right front pocket of my jeans very well, and that front pocket is dedicated to the iPhone. I was, as I mentioned, unhappy with the side milling finish on that cut, so I'm going to do two things. You'll notice the color of the end mill is different now. I changed it. This is a 3/4 inch high-speed steel uncoated end mill, and you probably can't tell from there, but it's not. I'm going to leave a little bit on the a little bit of material here, so I can take a 6-flute end mill and finish it up, hopefully, and get a better finish. With the 6-flute, I'll take a full depth cut and hopefully get a better finish. I'd like to have a better finish on the valve end and on the cylinder end, and not have to clean it up so much. On this end, it's just the pedestal. I'm cleaning that up. Here I'm taking 50 thousandths at a time, according to the plan I described earlier. Take the first pass on the length of this workpiece. I'm going to take something like 25 thousandths off to see how the mill and my setup like it. Obviously, there were no complaints from the mill of the setup. So I'm going to take 50 this time and see what happens. Obviously didn't mind 50 either, so I'll increase it. And you'll know how much I took when I turned the camera back on. Well, 100,000 doesn't seem to bother it, so sounds good to me. There's 100,000 off the side, 1 inch depth cut, 100,000. It's a low one. So it's probably not that big a deal. I'm sure I could take a lot more. But why do it? I guess you could do it if you were working for a living. Well, there it is, deburred a bit. I really like the finish that 2-flute end mill gave me on these vertical surfaces. I decided to use the 2-flute end mill to clean up the bad finish here instead of putting the 6-flute end mill in, because the 2-flute did such a great job. There's some there's some tool marks down here, especially on both ends where I dwelled, let the end mill rest in place while I fuddled around moving the table in or out. But they'll go away. I'll polish those out. It matched the surfaces real well. So next will be to take this section out. Starting to kind of take shape, isn't it? I don't know if Tubal-Cain to be proud, but there's a little bit larger version of his engine. It's longer. It's taller, I mean, like this. And the bore is a little over 3/4, while his is a 1/2 inch. My head, of course, is going to be square. His was round. But that's not going to hurt anything.